webinar coordinator. And the topic we have for today is Statistics of Industry 4.0 from a non-technical perspective. A couple of things before we start. We will have time for questions after the presentation. The best way to ask a question is to type it in the chat. So if something comes up to you, go ahead and type it in the chat whenever you need to. The same for technical questions. If you have issues, you can type it in the chat and I will try to help you. We will send out a note with your credit for watching the webinar after the webinar is over. Also, the video of the webinar will be posted to the YouTube channel later if you want to watch that later. And with that, I will introduce our speaker, who is Milton Krvochuk. I probably didn't do that right. Milton will have to correct me. He is the chair of the Master of Science Quality Assurance Program at California State University of Dominguez Hills, Carson, California. He has taught advanced classes in critical thinking and quality theories at California State in Fullerton, at Illinois State University, U of California, Riverside. He's also taught in several places overseas. Additionally, he has presented papers in Europe, the Middle East, Africa, and Asia, as well as countless locations throughout the United States and Canada. He is the past chair of ASQ Quality Management Division, also an ASQ Fellow, and a member of the ASQ Los Angeles section, 700 Simon Career Award recipient, and 2020 ASQ Section 701 Board Empire Quality Guru of the Year. He has several advanced degrees and many of the professional certifications from ASQ. Currently, he is president of Milton Krvochuk and Associates based in Wilmington, North Carolina, and a QCTS instructor with QC Training Minneapolis, Minnesota. So, Milton, feel free to mention the name and take it away.
Okay, all right, thanks. Thanks for that introduction. Krvochuk. So you're very close. Okay, well, it's great to be here. I always enjoy presenting and involvement with the various ASQ divisions and sections. As you can tell from my introduction there, I have a lot of diverse interests related to quality. My undergraduate degree is business statistics, and I have an MBA in addition to my doctorate in business. And that's kind of what the foundations are that are driving this presentation. As you notice, I'm going to correlate it to Industry 4.0. That's a major issue right now. It's affecting all of us. And I'm going to connect it as much as I can in the time allotted to me. This is a huge topic, and I could go on all day about it, but we'll keep it limited to the time allotted here. Also, I wanted to share that I'm involved currently with the Statistics Division Data Analytics Group, which is doing a lot of work with Industry 4.0. And I'm also on the Quality Management Division Content Management Team, and we're updating the body of knowledge and the resources available, again, with a lot of focus on Industry 4.0. And I'm on the TCC Committee for Quality 4.0. So I'm trying to stay right on top of all of these developments. And that's driving some of the foundations for this presentation that I'm making to you here today. And also, another comment that I get quite frequently is I teach Greenbelt training. And I've done it quite a bit in the Middle East and some domestically here in the U.S. And I can't tell you how many times I've heard from companies I've gone into, and they said, yeah, we want to take on Six Sigma, we want to be a Six Sigma organization, get a group of our key employees trained to be green belts, but don't teach statistics. Leave statistics out of it. We know it's in the body of knowledge of Six Sigma, but we don't use statistics. And I hear that very frequently from service groups, banking, insurance, retail sales. And there's just such a misunderstanding of what statistics are out there. And I believe that it really, these managers and these industries are missing opportunities because Industry 4.0, this is the age of information. This is the age of big data. There's more data than you ever need out there, and not using statistics to help evaluate it, you're missing opportunities. So you can tell I'm an educator here. I start with a dictionary definition of statistics, and I'm not going to read it in all this detail, but you can see it's very structured, and it's kind of intimidating, especially if you're a business manager and you're asked about statistics and you don't want to let them know what you don't know, and you provide an answer, and then you go to a dictionary and you look up statistics and see this, that can be rather intimidating. Okay, it's not. Those of us who do have a strong background in statistics, we understand that there are two different types of statistics. The inferential statistics, that's the theory, methods, practice of forming judgments about parameters of population, usually on the basis of random sampling. All right, well, inferential statistics, they have their place. We need them. The inferential statistics are pre-production. These should be in controlled environments, in laboratories, and I'll touch on that in more detail toward the end of the presentation. But this is pre-production. We would not be taking the COVID vaccine right now had laboratories not run an extensive amount of inferential statistical techniques and formulas and equations to validate that the vaccine is effective. So that's inferential. Descriptive statistics is really the focus of my discussion here. Descriptive statistics, the use of statistics to describe a set of known data in a clear and concise manner, as in the terms of mean and variance and diagrammatically by a histogram. Well, that's what we need to make fact-based decisions. I know the MBA school, anyone that's gone through and had an MBA, one of the basis of all the classes is managers should be making fact-based decisions. Descriptive statistics can do that, and for the most part, many organizations, many companies are already doing it, and they're not aware of it. And here's some of the popular misconceptions. As I said, I hear these very, very frequently. We're a service provider. Statistics have no value to us. Incorrect. We want to become Six Sigma focused organization, but there's no need to address statistics because we don't use them in our processes. Really? I find that hard to believe. If you want to use Six Sigma for process analysis, I believe you are using statistics, basic descriptive statistics, and do not even know it. And I've also heard this. I've come across in my networking. I've done extensive travels throughout the Middle East, and some in Asia and some in Europe. And I've come across companies that have exhibited at these conferences, and almost all of them have Six Sigma training programs. And I was just surprised to see that they, especially throughout Europe, have identified statistics as a black belt function. Statistics are not part of green belt. So they advertise that they're going to go in and train you to be a green belt organization, and there's no statistics. If you want to be a black belt organization, then they add statistics to it. I believe that's another strong misconception, and I can't believe that training companies are doing that because it tells me that they really don't understand statistics. And also business managers, they tend to think that statistics only apply to high volume production and laboratories. Now, statistics can be applied on a very small basis. Those of us that are familiar with the sampling plans, we know that one of the common tests that are used is the t-test. And the t-test is used for data points of less than 30. For the other statistical tests, usually they start at data points of 30 on up. So that's not high volume production. If your KPIs that you're measuring, as long as you have 30 data points, you're basically all set to do a statistical analysis. If you're not, then you can still use the t-test, which is statistics. And then the last one, this is a real myth that I just can't believe. We're getting along fine without them. So why implement them if everything's going well right now? Why stir things up? Again, I believe that they are using them, they're applying them, don't even know them, aren't even aware of it. And here's where I bring Industry 4.0 into this discussion. We are in a very unique situation right now, where as managers, the employees in the workforce are from 4 different generations. Now, the baby boomers, post-World War II to early 1960s, they're getting ready to retire. They've got a lot of the tribal knowledge, the tacit knowledge. They were educated very rigidly, very formally. The Gen Xers, very small group, only lasted about 10 years. Very small, but they were very dedicated. They're very driven to get the job done. Then we have the millennials, Generation Y from 1977 to 1994. These are the ones that grew up with cell phones and digital devices. They're the primary digital generation. And then we have the Generation Z. They're starting to enter the workforce now, just coming out of college, and some of them have never even seen a landline phone. They've developed an entirely new language. The emoticons, the texting shorthand, the acronyms, the abbreviations, the informality of communications. That's all acceptable to them. That is a real change going back to the formality of the baby boomers. So you've got all of them to communicate to. And the other misconception is that this is a digital generation entering the workforce. They are. But make note of this. Digital generation does not imply a focus on proficiency in numerical applications. It's primarily in communications and socialization. They are not experts in numerical applications. That's the statistics part of this presentation. So be aware of that. I always like to try to emphasize my point with more of a practical application than theory. And I've developed this fictional business situation case study. All right, and this is going to emphasize the communications and the statistics part of this discussion. You are part of a call center team which processes customer inquiries related to product performance information, complaints, and technical support. The business team lead's not comfortable with the overall department performance. Since COVID, most call team centers are working remotely. Team members are working remotely. Call center team consists of 5 employees from various generational groups. The company supports the generational mix to maximize the existing tacit knowledge that exists in the company from experienced employees, while the digital natives, as we call them, the ones who grew up with the cell phones and the tablets and smartphones, are a lot of the customer base. So this mixture allows these digital natives to effectively communicate with the majority of the customers who the product that you provide is generally Generation Y. They're the users. So the new team lead has been promoted from design engineer to business excellence team lead. And sorry I left this out of here, but this team leader is the Generation X, right up to the baby boomers. Okay, so that's the new team lead. And this situation's been handed down, and the team lead prepares this message, sends it by email. Team, we need to assess our performance in responding to customer inquiries and identify improvement opportunities. To develop fact-based improvement actions, you can tell that this is an MBA, a statistical analysis needs to be performed. All right, he's already sent chills up and down the spine of the Generation Y, the millennials. We will apply descriptive statistics on critical performance indicators. Visual representation of data is an effective starting point. I'm asking each of you to develop cumulative frequency diagrams using rational subgrouping of critical performance data in nominal categories, which, after analysis, can then be categorized in an ordinal manner. The first analysis of this data will take place during our team meeting next week. Wow, new manager, just come in. Can you tell this manager has a strong background in statistics? What about this grandiose language? Is this manager now the business team lead impressing the team with his or her knowledge? This happens. This happens very frequently. Okay, the message is out there. It's been received. And the 5 members of the team respond. Fred, who's the baby boomer, doesn't want to admit that he's lost. And he just says in his response, very formal, okay, I have some questions about this assignment. All right. Sue, Generation Xer, the other Generation X on the team. Can we have a brief, fun conversation about this assignment? They're very much in the Generation X, they like the face-to-face. But notice they're very formal. They accepted the assignment without question. Well, they accepted the assignment without question. They asked for some clarification. They did it in a very structured approach and basic good grammar skills. Abdul, the Generation Y, responds, I'll begin working on it. Abdul is Generation Y, but obviously comes from a different culture where you don't question management. And that particular country culture is you do what management tells you, even if you're not sure. Even if you have questions, you go and do something, and then if it's not right, then they suffer the consequences later. Now, that's another factor of what's taking place in Industry 4.0, which I didn't get into in this presentation. It's the different country cultures and how they respond to questions and address the work issues. And Teresa, Generation Y, look at her response. You want what? And look at what? All capital letters. This is the new form of digital nonverbal communications. You know, the traditional communication model said that 95% of the message is transmitted nonverbally by body action, by the tone of the voice inflection, by the facial expressions, those types of things. Well, Teresa has been able to do that by emphasizing what in capital letters, very emphatic. Then Adolfo, another Generation Y, he's probably real close to the millennials, probably just out of college. And look at his response. Impossible, a series of dots and LOL. What about that response? That's typical of what this next generation of the digital natives, as we call it, that they find that is a very acceptable way to communicate. There's only one way to do it. It's very informal, and regardless of authority, if they're sending this message to the CEO or even to their peers or to a customer, it doesn't make any difference. This is the way they communicate. Now, not being aware of that and being a new manager just coming into this, how would you respond to that message that you sent with those assignments? Well, the traditional approach, if you're the Generation X manager, Fred and Sue, all right, that's fine. Okay, Abdul, no problem. He's going to give me something. I'm not quite sure. I assume that he's going to give me what I asked for. He had no questions. But I got some issues with Teresa and Adolfo. Does that mean that they're problematic, that they're not dedicated to the job, they're not focused on what needs to be done. I could get that message from this type of response. Not really the case. We have to understand those generations. That's going to be a big part of Industry 4.0, especially the next couple of years as the baby boomers retire. The Generation Xers, there are not that many of them, and they'll be retiring shortly after. But we have to address these Generation Y and millennials that are coming in. They're looking at things completely different. So that's establishing Industry 4.0. Let's step back to my message. What did I ask of them? Cumulative frequency distribution in nominal categories. I asked them to plot a bell-shaped curve on their key performance indicators. That's all I was asking them to do in that grandiose statistical-based language. Is this something that we do every day? I know I've visited a lot of companies. I've gone in and done training. At one point in my career, before I moved into higher education, I was doing some ISO auditing, and everywhere I went, I saw histograms. That seemed to be a common chart that they kept, and they were charting KPIs. This is a basic form of statistics. This is a basic form of descriptive statistics, and most business managers aren't aware of it. So just for comparison, for this presentation, I asked for a cumulative frequency diagram. That's statistics. I wanted a histogram. That's the business explanation. Statistics, the terms are rational subgrouping. In the business, logical categories. Logical categories that we're measuring, what makes sense to do. Statistics, critical performance indicators. In business, we generally call them KPI, key performance indicators. Whatever the data points are that provides a basis to analyze how we are performing. Critical performance indicators, KPIs. Nominal categories. All we're doing is taking the numbers, the values, grouping them together to analyze. Just grouping for analysis. That's all those columns on that histogram. Grouping for analysis. An ordinal manner. Ordinal. That's developing priorities. That's basically a Pareto analysis. Pareto analysis is taking the nominal categories and placing them in an ordinal manner. It is strictly by total value, the number of instances, the number of data points that we're evaluating. So nominal categories moves to ordinal categories. Ordinal Pareto. Managers typically do not make that comparison. Now that we know this, and after some coaching and some meetings and some confusion, let's bring that business team lead back down to the real world. Let's get him or her out of the statistical world and get them into the practical business world, but we're not abandoning statistics. We're still using statistics. So let's rephrase that. Business team lead. Team, we need to assess our performance in responding to customer inquiries and identify improvement opportunities. To develop fact-based improvement actions, key performance data needs to be analyzed. Visual representation of this data is an effective starting point. I'm asking each of you to develop a histogram of your individual KPIs. First analysis of this data will take place during our team meeting next week. Same requirements as that previous message, only instead of being worded in statistical terms, I've just put it into key business terms, and I'm sure that that team, 5 members of that team, would be able to act on this without any further explanation. And it's not really a major undertaking that he's asking them or she's asking them to do. Just take your data points, put them in a histogram, and then let's look at it and see what we have. But it's still statistics, descriptive statistics. In the business world, we need this. These are the most common areas of mean, median, and mode. The most frequently occurring value, the midpoint of the data, and the average of the data. This is important for a basis for analyzing performance, how well we're performing, how much spread, how much raw variation is there by numbers in our process. It gives us a starting point. It gives us a baseline. We just can't say we're doing a bad job. We can quantify it, and it becomes a business case. Is the amount of variation just in raw numbers between the high and the low value? Is that adequate? Is that satisfactory? When those questions are answered and we have a quantified baseline, we can then identify improvement activities. We can start to look for opportunities to make changes in the process or in the products. That is basically descriptive statistics in its fundamental activities. And once that's in place, and most organizations already have that, they're doing it, from this KPI data, and today the age of information, computers can generate literally dozens of reports and numbers and numbers and numbers. And numbers is just numbers unless you evaluate it and do something with it. And a good starting point is just doing a line chart. Okay? This is really not advanced statistics, but we are analyzing data by placing it in a visual representation just to see how it's behaving. That's a good starting point. And I'm sure that once this begins, and you have this and you get into more discussions, and managers start looking for acceptable levels of performance. This is on total sales, but you start looking at a process on the output, identifying the average. We can then evolve into control charts. In the line chart, it's the raw data points. Control charts, we need to add the average outputs. And we've got the data points. The data is already there because we plotted them. We just need to add them up and calculate the average. Only in statistics, we tend to get a little more sophisticated. We don't use it. We don't call it the average. It's a sample, so we call it X bar. And for business managers, they say, huh? Well, what is X bar? Well, it's just the average. Okay, so we've drawn that correlation. And now we want to know, what is the natural spread for this? How well is this process performing? What's its upper control limit and lower control limit? Well, this takes statistics one more level. Okay, to calculate the control limits, we need to know a standard deviation. Sorry, I should have advanced it. Standard deviation, which will provide us a measure of dispersion. As we saw here, a natural process has 3 standard deviations above the center line, 3 standard deviations below the center line. That is a normal behavior, a normal process. It's accepted concept throughout the world for statistics. So to construct a control chart, we need an equation. There's many software programs out there that can do a standard deviation. It's just a matter of entering the data points in. You already have the data points. They're the KPIs. So you have them, you enter them in, and you get the upper control limit, 3 standard deviations above, 3 standard deviations below. Now the manager has a historical visual representation of how the process is performing. The term standard deviation, okay, I'm sorry, jumping ahead of myself here. And then you can plot these. and you can see visually how much variation there is. And logically, we want a steep curve. This is a normal distribution. And the steeper the curve, these are the data points, the KPIs that are plotted, 3 standard deviations above, 3 standard deviations below. That's the behavior of our process. The narrower it is, the less variation. Now here's another example. Again, the process is in control. It's a normal bell-shaped curve when you plot the points, the KPI. But notice there's more variation, larger spread. Well, that's getting into what I consider intermediate descriptive statistics. Intermediates. This is taking it to the next level. So now managers have a better idea of just how much variation there is in the process, and then they can compare that to the profitability. How much money are we making? How much money are we losing? The time, the amount of hours that we're spending, maybe the amount of material we're consuming, whatever our KPIs are, it provides us a visual representation for decision making. Where I almost jumped ahead here a couple minutes ago, this is the formula for the standard deviation. All right, and this is intimidating. And here's the square roots. This Greek symbol summation is epsilon is the sum. X is our total number of data points. How many measurements did we take? How many KPIs do we have? X bar is the average. N minus 1 is the sample size. And we take the square root. Okay, that can look rather intimidating, but if you have a software program such as Excel or even some of the old TI calculators, you can enter these data points and you can get a value very quickly. I think the problem that I've come across when I've had discussions with managers and we talked about standard deviation, they really didn't understand it. They didn't see a practical value to it. And they couldn't make the correlation of using a standard deviation to construct a control chart so they could see the upper and lower control limits of a process to determine how well it's performing. So this is a fundamental requirement here to do a standard deviation. So I encourage managers, especially when I do Six Sigma training, that they at least take it this far, at least to this point. That's the basic descriptive statistics that I think businesses should all be using, at least to this point. Whether they choose to go beyond it would depend on the maturity of their data analysis group, or their quality group, and also how well the company's performing and how competitive it is, how profitable it is. At least up to this point is what I recommend. The development of control charts is basic depth of descriptive statistical applications I feel necessary for analyzing processes from a business and quality. I'm an MBA first, I'm a quality person second. If I was back in business setting today, an environment today, my department would have control charts for our key performance indicators. I would not accept just pure numbers and pure data for discussion. The basic application of descriptive statistics can be advanced by application of various probability distributions. I'll touch on that here in a couple minutes, but I don't think it is necessary, at least in my department, if I'm in the business world today, working with customers, realizing that I've got constraints on time and money, and I want to keep customers happy. Unless I'm in a very serious situation that I've got a process that's underperforming or a product that's underperforming, I would not advance the application into probability distributions. Probability distributions and hypothesis testing get some more granular information related to process performance and improvement. Those of you that are familiar with Six Sigma, you know that the Six Sigma body of knowledge, both the green belt and the black belt, really do take it to that more advanced probability distribution, hypothesis testing. In all of my encounters globally, I have probably not encountered a half a dozen companies that get involved with Six Sigma that take it into probability and hypothesis. They're satisfied with control charts and analyzing control charts. In the business world, generally the bottom line financial impact is acceptable in support of process improvement and performance effectiveness. We have values that we work to. Management sets a standard, design sets standard, customer satisfaction is another key issue. And if they're in acceptable range, it becomes a business case, a business decision, then the impact of the process or the product is acceptable without the statistical evaluation. I agree, opportunities are not being capitalized on, they're probably being missed. But this is the business world, okay? We don't have a perfect world out there. It's fast, it's competitive, and we've got to stay on top of it. Just a little word about inferential statistics. Yeah, it's a must for pre-production. And setting needs to be closely controlled, such as in a laboratory. Design of experiments, very effective. Okay, design of experiments before we get into production, before that COVID vaccine was released, before it was made available to the public. Design of experiments had to be run so that we were comfortable and confident. The drawback for production, why we don't do more design of experiments, it's time consuming and it can get very expensive, and we might not ever get the ultimate result. That's what design of experiments objective is, to optimize it, to optimize the process, the product, the processes that we're experimenting with. From an MBA perspective, I don't recommend it for existing processes that involve customer satisfaction. I don't want to run experiments on live customers. I'm very conservative when it comes to that. I will say that there are software programs being developed that can simulate customer satisfaction. Those design of experiments are making a lot of progress. They're inferential statistics. I'm in favor of them, but I'm not seeing wide applications for them. So you're not going to run a DOE on any of my live customers. And I just would not let that happen in my department. As I mentioned earlier, this is something else that intimidates managers when they start to look into statistics, and we have a discussion. And this again is some of the feedback I've had. I've done some training, and then a manager said that they went home that night and they looked up statistics, and they get hit with this types of distributions: normal, exponential, Weibull, uniform, bivariate, exponential, log normal. What about paranormal? I've had that asked. Paranormal distribution like the log normal? Okay, hope you get the joke there. This is all for continuous data, which I have to explain. Continuous data is data that's measured. And then we move into discrete, measure that's counted, measurements that are counted. We have binomial, Poisson, hypergeometric, and multinomial. And the managers say, you want me to do what? You want me to, these statistics? I'm lost here. I've got enough problems day to day with customers and processes and trying to look for improvements. And this really is in more depth and detail than I really need to make these kind of business decisions. So you can see if you don't have a strong statistical background and you see this when you open a book to learn a little bit about them, it can be overwhelming. I hope I've taken some of that intimidation away from you in this presentation. In summary, business and quality environment, basic descriptive statistics already exist. Many managers just are not aware of it. All right, if you're doing anything at all in the way of analyzing data, you are applying some basic statistical techniques. Here we are coming into Industry 4.0, big data, predictive analytics, blockchain, with the overwhelming volume of data currently being generated in Industry 4.0, basic statistics are required to make sense of this data and extract the data necessary for developing informed decisions. This becomes a business case. You have to understand what data needs to be analyzed. And here's something else that doesn't take place in Industry 4.0 yet, but we're working on it. It's artificial intelligence. It's taking this data and placing it into context. Dr. Deming, and he said the value of data is placing it into context, putting it into perspective, looking at trends, looking for comparisons. Standalone numbers mean nothing until you place it into context. And artificial intelligence has not been perfected in that area yet. We are making strides, but you as managers who are in, as we call it, Gemba, day-to-day, where the action is you're dealing with these numbers, these values. It's placing this data into perspective, and it takes some statistics to analyze it. Statistical terminology might appear to be grandiose language, but the concepts of analysis help to support practical applications. I know in my experience before I left industry, when we hired some engineers right out of college, and they came in and they tried to impress us with their vocabulary and understanding, speaking in this grandiose language that they learned in college. And when it comes into the business world, it's, as they say, where the rubber meets the road, Gemba, where the action takes place. And if you can't communicate effectively with everyone around you, the people that are doing the work, your customers, your peers, and your managers, you're not going to be successful. And also, decisions supported by data are more reliable. And you'll find that managers who have MBAs will listen to you. If you come in with complaints, you're having a bad day, you have issues, they're generally pretty good listeners. But for the most part, they won't take any action until you bring them data. You bring them some facts. You bring them some information. Data transformed into information. And to make that transformation, generally it requires statistics, whether you call them statistics or not. So we have a business problem. Just a little circular flow chart here in the bottom. We analyze it, and we apply some statistics. Even if we have subjective data, even if it's anecdotal, we've got quality tools that can turn subjective data into quantifiable data. We can apply numbers and values to it. As soon as we have numbers and values, we can apply statistics. So we analyze the problem. We analyze, provide statistical, fact-based, number-based solution opportunities, develop the solution, and implement it. And then we start all over again. As we said, quality is a race without a finish line. We always are looking for improvement opportunities. Well, that brings me to the end of my presentation. And as I said, I did a brief introduction here. I hope that I raised some awareness issues related to the multi-generations that are out there in the workplace, the challenges of communications that are generational as well as cultural, and the different terminology and understanding of terms and concepts and applications of statistics and how they are also applied very similarly in the business case and known by a completely different completely different vocabulary. So if I've raised that awareness with you, consider my presentation a success. So with that, I've come to a conclusion here, and I believe we do have a few minutes left for questions at this time.
Great. We have a couple of questions. There was a comment that you mentioned DOEs are time-consuming and expensive, but making a bad product is even more expensive. Wouldn't you agree?
Yes, I absolutely agree. But that's why I tried to make the distinction there. the DOE was part of inferential statistics, and inferential statistics should be done in a controlled environment before that product's released to production. I realize you can't always do that, but that is the ideal situation to do a very intense, involved DOE before you begin production. If you don't do that before production, then you're probably going to have a lot of problems out there, and I don't know the DOE the best case if it's already in production.
Great. What is your take on using control charts for non-normal data?
I'm sorry, for what kind of data?
Non-normal data?
Non-normal data, okay. Good question. The non-normal data is a big issue that's coming up right now with predictive analytics and how the non-parametric data, as we're calling it, coming from unstructured sources. Is that what you're referring to, the non-normal data from these unstructured sources? Kind of, social media, chat rooms, blogs, and those types of issues?
It wasn't specific.
Okay. I have an absolute suggestion at that time, other than to try your best at normalizing it. All the statistical techniques that we have are based on normal data. And we have the central limit theorem, of course, if you have, it's often used in laboratories when we're just beginning, just gathering data, and we don't have a normal distribution. We can artificially construct one with the central limit theorem. But I think this is, again, this is purely my opinion, and it hasn't been documented yet. I see that it's getting addressed in a lot of areas, but we need to find a way to normalize the data. And I think by gathering the data, working with a team of subject matter experts related to whatever the topic is, the area that we're analyzing it, and then taking that non-normal data and probably breaking it into an affinity diagram and seeing if you can categorize it, if you can start to make some sense of categorizing it, which is basically the rational subgrouping I talked about. If you can start to break it into those categories with a rational subgroup, then you can logically move into a Pareto and possibly even a statistical analysis from there. But the definition, the working definition of this non-normal data and what's coming in has to be what's time and correlated directly to your problem, your issue, your objective, what you're trying to resolve, and see if you can make the connection. And we do have other quality tools that can do that for you as well. I know that's not a really good answer, but I don't know that we have a good answer out there just yet.
Another one is, would you consider predictive modeling a form of a design of experiments, and what places in manufacturing would benefit from that?
I'm sorry, what was the first line of that? What was it again?
Would you consider predictive modeling a form of design of experiments?
Yes, I would. I would consider that predictive modeling. And I guess that is one case, predictive modeling, I hadn't taken into consideration. And if we are going to consider that design of experiments, which I don't think predictive modeling is in the body, is formally considered a design of experiment, even though I think it could be one. Yeah, then I could amend comments about DOE not being applicable in a production process, but predictive modeling could apply. And that further supports something else that I believe in, I didn't bring up. When we're discussing quality, it's not black and white. There are always gray areas. And even if the predictive modeling is not in the DOE, is not considered a DOE, I could see where I could help to make a case for it to consider that it would be a design of experiment. That would be on an individual case basis, related to the product and the objective.
Okay. Well, I think we're about done for today. I'll be sending out an email with the credits for the webinar, and then we'll have the links posted on our YouTube channel. And I want to thank Milton for the very good presentation and everyone for being with us today. Thank you very much.
Okay, thank you.